Hello everybody and welcome to this Copernicus Marine Service training. I'm Etienne from NOVELTIS, and today I'm going to show you an exercise on oceanic fields from the Copernicus Marine Service over the South African region. The seas of the southern African coastline lie amongst the most dangerous places to sail and are one of the regions of the world particularly prone to maritime disasters caused by strong winds, powerful surface currents, and freak waves, amongst other factors. According to Mertz et al. 2012, such tragic events may result in large human, economic, and environmental casualties, including loss of life, loss of commodity, and/or black tides. However, more and more inexperienced pleasure ship owners are now sailing during weekends and holidays along the South African coastline. These vessels are the most at risk in these restless waters. Hence, monitoring surface currents, wave heights, and winds is of prime importance to determine the maritime safety in these areas. The parameters in the Copernicus Marine Service products constitute key assets to detect the regions experiencing the roughest sailing conditions. They can be used as a decision aid to prevent a commercial vessel from running into hazardous conditions or to assess whether it is safe to take out a pleasure craft. In this training, we will show you how to monitor the Agulhas Current and the surface wave height fields in this region to set a safe shipping route according to waves and current conditions close to South African coast using QGIS and the Copernicus Marine Service products. QGIS is a free software that allows to manipulate multiple meta-ocean and geographic data. CMEMS data have a common NetCDF format which enables to handle several complex variables. And in order to facilitate the manipulation of NetCDF file, NOVELTIS has developed the NetCDF to GIS plugin, which can be easily installed following the steps described in the user manual of this training. All additional material used in this training is also provided with the user manual. First of all, we are going to set a new QGIS project and add a background layer. So here you can select project and new to have a new untitled project. Now we are going to add a background layer, so we select layer, add a WMS layer, and here you have to connect to the map server demo. Click connect, and now we can select the blue marble layer here. We are going to add this layer to our QGIS project here in the background, and now we can close this window. Okay, here you have a background for your map. You just have to check that the projection is 4326, which corresponds to a longitude-latitude projection. Now we are going to map the Copernicus Marine Service products. And first, we are going to open the NetCDF to GIS plugin to load northward and eastward seawater velocity from the Copernicus Marine Service. Here you can open the NetCDF to GIS plugin and click on plus to import the first file. We are going to select current products, and we are going to select products from the Copernicus Marine Service, a global analysis and forecast model, which is distributed with a daily temporal variability, but we have downloaded it with a monthly temporal resolution. Here we select the file corresponding to the month of February. The mean value of U0, V0 on the month of February. Here you have access to all the dimensions and units of the Copernicus Marine Service product. And if you go to metadata, you have access to the spatial resolution, which is 1/12 degrees. You have access to other attributes of this CMEMS project. First of all, we are going to display each component of the current vector field. So we are going to display U0 and then V0. To do so, you are going to select the first variable, U0 here, right click on it and select Add Layers. Here we have only one date and one depth, so we can click directly on Add and Close to add it to our QGIS project in the background. If we zoom in, we can see that we have the eastward seawater velocity field here around South Africa. Go back to the NetCDF to GIS plugin and do the same with the V0 layer for the month of February, so the austral summer. We are going to do the same, add and close, and now we have the northward seawater velocity field in the background. In order to compute the current vector field, we are going to merge and these two layers, and thanks to the NetCDF to QGIS plugin, you have access to the function vectorize here. Here you have access to a lot of options, so we are going to display UV components, a current field computed on UV components. On the eastward component we are going to select the U0 layer, and on the northward component we are going to select the V0 layer. Here we can change the norm of the computation of the vector field to current, and we are going to apply a downsampling of 3, which means that only 1 out of 3 arrows of the vector field are going to be displayed, and it is more convenient. Here you can select an output directory for your vector field, and we are going to rename the vector field to current field for February 2021, and then you can click on vectorize. You can see that a vector field have been computed and displayed on the background of your map, so you can close this window, reduce the NetCDF to GIS window, and we are going to zoom on the South African coasts. Here, if we just uncheck the two layers, the two scalar layers for the eastward and the northward component, and we only keep the vector field of currents around South Africa, we can clearly see here a strong current along South African coast, which is the Agulhas Current. Now we are going to tune the representation of this current. To do so, you just click on the layer, right click on it, select Properties, and we are going to load a file, a style file, to change the value range of each step of the vector field. To do so, you can just click here on Style, Load Style, and here we are going to select load Style from File, and here we are going to browse to find the current scale point Qml file of styles. You can click on Open, Load Style. So we are going to display a current field from 0 to 2 meters per second. Just click on Apply and OK. So this new palette highlights the strong current values along the South African coasts. So we can clearly identify the Agulhas Current along the southeastern African coastline here with the red arrows. Now we are going to do the same for the months of July and the austral winter. So go back to the NetCDF to GIS plugin and load the NetCDF file corresponding to the month of July. Here we are going to add layers for the U0 component again. Just uncheck override group in order to add this U0 layer of the month of July to the existing U0 group here. Click on add and close and do the same for the V0 component. Remind to uncheck the override group here. Click on add and close. And now we are going to compute the vector field for the month of July. So you can select the two layers with Control or Shift on your keyboard. Right click on it, select the vectorize function. So just check that UV components are selected here, that you have the good U0 and V0 layers corresponding to the month of July. We are changing the norm to current, the downsampling to 3, and just rename the file name to current underscore field July 2021 and click on vectorize. Once it's done, you can close this window and go back to your QGIS project. So here we can just uncheck the current field for the month of February to see how it's in July. And if we uncheck the two scalar components, U0 and V0, we can see that we have again the Agulhas Current along the South African coast. We are going to apply the same style with the same color scale and palette from the month of February to the month of July. To do so, you can right click on the current field for February, going to Style, Copy Style, and copy the symbology, and select the current field of July, right click on it, go to Style, Paste Style, and select symbology. Now we have the same ranges for each current field, so we can compare the two current fields. So if we check and uncheck each current field, for example in February and then in July. So in February we can see that the strongest values of the Agulhas Current are here, south of the South African coasts, and in July it's more eastern here and close to the coasts. Now we are going to see how to export a vector field layer as a GeoJSON format. So if you select, for example, the current field of the month of February, right click on it, you can select Export and Save Feature As. Here you can select the format to GeoJSON, select the file name, and for example here you can save your layer as current field February 2021 with a GeoJSON type. Click on Save and OK. So QGIS is generating a new vector field at the GeoJSON format, and the layer is then displayed with points. But you can now uncheck this layer. In the following, we are going to map the significant wave height around South Africa during the austral summer, and then in February, and then during the austral winter, to see how the significant wave height fields vary in between the two seasons. What you can do here is just uncheck the vectors layer and go back to the NetCDF to GIS plugin. Here we are going to import significant wave height products. So go back to your directory and select the global analysis forecast data corresponding to your month of February, and click on open. So this data is extracted from the global analysis forecast model from the Copernicus Marine Service with 3 hours temporal resolution. And if you go to metadata, you can see that the spatial resolution is 1/12 degrees as well. Here you have additional informations about this product. Now we are going to display a little animation of some time frames of this product of significant wave height in February. So if you select the VHMO variable, which is sea surface wave significant height, you can just right click on it and select sequence layer to do a short animation. Here you can select the first time frame you want to display. So we are going to select the 3 of February at 15 and press Shift on your keyboard, and now we are going to display layers until the 5th of February at 15th. Here you can just rename the group to sequence February. We are going to display layers selecting the minimum and maximum values for each layer in order to highlight local maximum of significant wave height. We are keeping the spectral palette, and here we are going to keep 1 second for each layer. So it's going to create an animation where each time frame will scroll during 1 second, and so on. So you can click on Start, and if you reduce the 2 panels, you will see this animation of the significant wave height from the 3rd to the 5th of February. So here we can spot local maximums of significant wave height coming from offshore to the South African coasts. Then you can go back to the NetCDF to GIS plugin and the dialog box and stop the animation. You can close the dialog box. And now we are going to work with only one layer of the sequence February group. So here you can just uncheck all these layers by clicking on the boxes, and we are just going to keep the layer of the 5th of February at 3 here, and we are going to tune the value range and the color bar. to highlight the significant wave height maximum on this day and this hour, and compare it with the maximums of the mean current field in February. To do so, you just have to right-click on this layer, open Properties, and now we are going to change the minimum value to 1 meter and the maximum value to 4.5 meters. Here we are going to invert the color ramp to have blue colors for the minimum colors and the red colors for the maximum significant wave height. And we are going to just change the equal interval mode and select 8 classes, and then you can just reduce the label precision here to 2 decimals. Now you can just apply these settings to your layer. Click OK. So here we have a significant wave height maximum pattern here and here. Now we are going to apply this value range of significant wave height to all the other February patterns and layers. So right click on it, select Style, Copy Style, select all the February layers with Shift on your keyboard, right click on it, select Paste Style here, and again if you select each layer, so you can see the maximum of the significant wave height just coming from offshore to the South African coasts. So we are going to work only with this particular layer, and if we select this layer and just go back to our vector group, if we take the current field on February, the mean current field in February, we can just activate it and select this vector group and just put it in top of the significant wave height fields. If we zoom to the South African coasts here, we can clearly see that the maximum significant wave height areas are concomitant with the strong Agulhas current shown in the first part with this vector field in February. Here, it's really clear. Now we are going to do the same steps with the significant wave height in July. To do so, you can go back to the NetCDF2 GIS plugin and load the Global Analysis Forecast for waves corresponding to the month of July 2021. Open it. So it has the same characteristics with the month of February, because it's the same product from the Copernicus Marine Service. Select the VHMO variable, right click on it, and select again Sequence Layers. Now we are going to sequence layers from the 2 of February at 15 to the 5th of February July, sorry, at 6 here. Just remind to rename the group here to sequence July, and we are going again to highlight minimum and maximums for each layer. You can now launch the animation, clicking on Start. Go back to your QGIS project. You can just uncheck here the current field. But you have to and now you can see that the significant wave height maximums are located here at the beginning, and then going from west to east and along the South African coast. Now you can go back to the dialog box and stop this animation and close the dialog box. Here we can just uncheck all the layers, and we are just going to display the 3 of July at 21, this layer. Again, we are going to set the value range for this layer, so just right click on the layer, open properties. We are going to set the minimum value to 2 meters to 9 meters, so we can see that the range is higher than the range in February. We are going to invert the color ramp, select the label position to 2, and here select an equal interval with 8 classes. Click on apply and OK. So we can see that we are highlighting this pattern of significant wave height maximum in July. Again, you can just copy the style of this layer here and apply it to all the layers in July with Shift, select all the layers and paste style. So if we see other layers, other time frames in July, we can see the significant wave height maximum also. What we can do in order to compare the amplitude of the significant wave height between July, so the austral winter, and February, the austral summer, we can copy the value range and the style of the layer of the 3rd of July. Right click on it, select style, copy style, and we are going to apply it to the layers of February. Right click on all the layers selected with Shift on your keyboard and click on paste style. And now if we compare the 2 layers we have selected, one in the summer season and one in the austral winter season, we can see that the significant wave height in July is higher than the significant wave height in February. And we can try all the layers of February. We do not have significant wave heights which are at the same level at the significant wave heights in July. So it's really interesting to see that there is a variability in significant wave height between the 2 seasons. Now what we can do is compare the field on the 3rd of July at 21 with the vector field, the mean current field in July. So we are going to activate the current field in July, and again select the vector group and drag it on top of the sequence July group. Now we are going to zoom on the map, and we can see that in July we have also a concomitant Agulhas Current here with significant wave height patterns on the background here. So if we activate again the vector field, you can see maximums of significant of the Agulhas Current here, and in the background maximum of significant wave heights here in red in the background, and here in red in the background. And we have seen that we have strongest significant wave heights in July in the austral winter in comparison with February in the austral summer. Now we are going to do an exercise to define a safe shipping route between two harbors during the austral winter. So we are going to work with conditions in July. So we can just reduce this group, uncheck the sequence February, and we are going to use the significant wave height and strong seawater surface current maps from July to create this route from the harbor of Durban to the other harbor of Cape Town under hazardous conditions. To do so, we are going to use data from the World Port Index, which have been downloaded before. So these data are a global database which provides harbor locations around the world and multiple additional information such as their size, country, or etc. So this shapefile can be added to the project using layer, add layer, and add a vector layer, because the shapefile is a vector layer. So we are going to browse here and select external data and select the shapefile object from the World Port Index. Click on Open and add it to your project. Click on Close. Just drag your World Port Index shapefile out of the vector group here. So you can see here you have some points which are the different harbors of the world, and here of the South Africa. First of all, we are going to filter this shapefile that contains a lot of data, as you can see here, all around the world. And so we are going to filter this shapefile and this data to only select harbors on South Africa. So we are going to right click on the WPI layer and select filter. So here when you click on filter in the query builder, you can just select country or type it with your keyboard and select equal ZA, South Africa. Just click on test. Only 8 rows are corresponding, so the 8 harbors of South Africa, and just click on OK. Now you can see you have only those 8 harbors selected. Now we are going to tune the representation of these harbors. To do so, we are going to use a QML style file already prepared and available in the user manual, with the user manual, to classify harbors by sizes, from very small harbors to large harbors. To do so, you can just right click on the shapefile layer, go to properties, and now we are going to select style and load a style from a QML file. So just load style from file, click here to browse, and we are going to select our style underscore WPI underscore size.qml file. Click on open and load style. So you can see that large harbors have bigger symbols than very small harbors, and we have setted different colors. So you can click on apply and OK. So here you can see that you have information on the harbors names and their size according to the size of the dots. You can just uncheck the vector layer to see it clearly. So now we are going to create a new shapefile layer to draw a safe route between the Durban Harbor to the Cape Town Harbor, avoiding hazardous conditions. So if we activate the current field in July and the significant wave height in July, we see that we are trying to follow the Agulhas Current here, but going close to the coast in order to avoid significant wave height maximums here. So to add a new shapefile layer, we are going to select here the new shapefile layer icon, click on it, and select a file name for this new shapefile layer. So we are going to select the safe shipping points Durban, Cape Town, and the dates 3rd of July 2021. Click on save. Here you can select the geometry type points and just check that the projection is 4326 longitude latitude. Then you can click on OK. Now we are going to activate modifications on this empty layer. So you just have to click on the pen icon here, toggle editing, and then click on add point feature here to activate this layer and to be able to add points. So now you can draw the route and just click on the first harbor here, and so this window open, and here you just have to give an ID, an index to all your points. So we are going to start at 0, and then we are going to add several points, 1, and so on, following here the Agulhas Current. And before coming to high significant wave height patterns here, we are just going close to the shore here at the level of Port Elizabeth, and just increasing the indexes. Here you can see that we can follow this current patterns here going south. And here just we are finishing at the Cape Town Harbor. So here you have all your points to define your shipping route, avoiding huge significant wave heights here, and benefiting from the strong Agulhas Current along the South African coast. Once it is done, you can close the toggle editing tool here, clicking on the icon again, and just click to save the changes you have brought to your layer. Click on save. Now, in order to have more visibility of the points we have selected, we can just go to the properties of this layer, right click on it, click on properties, and we are going to just change the size of the dots. So here you can just increase the size of the dots to 5 and change the color. Click on apply and OK. Now you have your dots visible here. For the moment, this layer only contains the indexes of your points, and it will be more practical to have the points coordinates. To add these coordinates, so we are going to use a processing tool. To do so, you can just click on processing and open the toolbox here on the right, and here we are going to select the add geometry attributes function. Just double click on it to open it. And now we can just select the actual safe shipping points layer here to add geometry attributes. So you just have to click on run and a new layer is created. Close this function. And now if we go to this new layer, right click on it and go to open attribute table, we have access to the attributes of this new layer with the indexes of our layer and the associated x coordinates, so longitudes, and y coordinates, latitudes. So if you want to export this layer with coordinates, you can export it as a comma separated values file, which is convenient to treat it in other softwares. So just select your layer, right click on it, select export and save feature as, and here we are going to change the format to comma separated value. We are going to change the file name to points coordinates and select save. Now you can click on OK and override the file because it's already existing in my case. So the last step of this exercise consists in joining our points in order to get lines. So to do so, you are going to select the points layer with added geometry informations. We are going to open the toolbox again, and we are looking for in the vector creation group, we are going to select the points to pass function here, this one. So you can double click on it to open it, and we are going to add the added geometry info layer as an input layer here, and then you just have to run the function. Now you can close this window, and you can see that we have here lines between all our points. We just can change the representation of these lines to have thicker lines. So to do so, you can just right click on this layer and open properties. Select dash black line and just increase the width to 2. Click apply and OK. So here, if you deactivate or uncheck the added geom info and safe shipping points layers, you have your safe shipping route drawn, and you can see that you are benefiting from the Agulhas Current and avoiding strong significant wave height patterns. Then the last step of this training is just to export this path and these lines between points as a shapefile. To do so, you can right click on your layer, select export, save feature as. We are going to change the format to S3 shapefile, select a file name, so 37 path. I will add an index 1 to avoid overwriting my old file. Select save, and now you can click on OK. And here you have a new shapefile loaded into your directory, which represents the path of your safe shipping route with lines. So we saw in this training how to use QGIS, a free GIS software, and a NetCDF to GIS plugin to easily handle NetCDF file format from the Copernicus Marine Service, data and products of currents and waves, to analyze conditions, oceanic conditions and sailing conditions, and to add context with WorldPort index data to draw a safe shipping route between 2 harbors according to a date and the actual sailing conditions of this date. So now it's your turn. Just select other months, other conditions, and you can apply this scenario with other dates and areas of interest. And so just go to the Copernicus Marine Service and download other data to set your own shipping routes. Enjoy!
Thank you.